All right, next, we've been talking about those programming structures, the if type statements, if else statements. Now we're going to get to dealing in more detail with logical expressions or Boolean. I really should have made this title Boolean expressions here. So let's get started. We know true is true, false is false. Sounds very philosophical in a way, but I think we know that's true. However, the integer 0, the floating number 0.0 or 0.00, an empty string, the none object in Python, and other kinds of empty data structures, more or less, are considered false as well. This is interesting, and you can make use of this in kind of neat ways, I think. It's even more flexible than R in this way. And everything else is true. Okay, so if it's not a 0 or a 0.0 or an empty string or a none or some other kind of empty data structure, more general data structure or more specific, whatever it is, then it's going to be true. So let's evaluate, just thinking through this. If 0, which, how is that going to be evaluated? False, right? False. So if 0, print high. So are we going to see high printed? No, because it gets evaluated as false. If 4, and how is the 4 going to get evaluated? As true, because it's not 0. It's something else. Everything else is true, right? So if 4, print by. So we will see by. We won't see high. If we run this whole string, try it out, you'll just see by. Okay. When an expression contains a connector word like and or, so we use these. Python is really efficient, more efficient than R. I've gone into evaluating how these logical expressions get used within R, and the Python evaluation is even more efficient. And let's pay attention to how they get evaluated. So first of all, when looking at these connecting Boolean expressions with an and or an or, Python evaluates left to right. That's important. Just like we read, at least read in English, we're going to read from left to right in the code. It's going to stop evaluating once that truth of the expression is known. That's really key. So what are we talking about? What does that mean? Let's unpack it a bit. If it says X and Y, and X is false, then it doesn't even need to get to Y. It won't even evaluate it. Why? Because we already know X and Y is going to be false once X is evaluated and known to be false. Now, on a simple, like if we have Boolean, and it's simple, that doesn't make much computational difference, if any, at all. Okay, but imagine that your X and your Y are complicated expressions that require considerable computational resources, then you've really saved a lot of computational cost by having this left to right and stopping evaluation once the truth of the value, using logicalness of the values to be able to stop evaluation when you can. Okay, then X or Y. What if X is true and we know it's X or Y? Well, we don't need to evaluate Y. We already know it's true, right? So X or Y, if X is true, you stop. If it's false, then of course you keep going. And I should have pointed out here, if in X and Y, if X is true, you have to go back, you have to keep on and evaluate Y, right? Because if it's true, then it's true. If it's true, false, then it's false. The value of the expression ends up being the last condition actually evaluated by Python, by extension. Okay, so here's some examples. Let's just run through these. False and true, right? False and true. So what will it be? False. True and false. False. True and true. True. True or false